Hi there everyone, welcome back to the channel. I'm the GCSE science teacher. In today's video we're going to be talking about reaction time, and this is a required practical for GCSE Biology students. So if you do enjoy this video, feel free to give it a big thumbs up so I know. Also feel free to share this with someone else you think would benefit from learning more, and also do subscribe if you haven't already. Thank you so much to everyone who has already subscribed or left a nice kind comment or liked my videos or shared them. I'm so grateful for everyone who has done that. It's really lovely of you to do so. And if you've just simply viewed the video and you found it helpful, and that is wonderful to know as well. So thank you ever so much. Let's get started with this video. So reaction time, what do we mean by that? Reaction time is the amount of time it takes someone or something to respond to a given stimulus. Remember, a stimulus or a stimuli is a change in the environment. And this can actually be seen in real life. So if anyone is looking to start to learn to drive in the next few years, or maybe you're learning to drive right now and you've come across this video, reaction time is actually something very important for that particular skill, because lots of things can actually affect our reaction time. And that's why things like alcohol consumption or drug consumption, even like caffeine consumption or amount of sleep, or even things like the noise level in a car can actually affect how quickly you can react to the outside environment. And that can actually lead to dangerous hazards. So that's why a lot of these things, such as drugs and alcohol, are banned when when driving around. But also the amount of sleep someone gets is really important and vital so that they can respond quickly. So our reaction time is something that kind of we see around the world as well, like just in other circumstances, not just in the GCSE exam, of course. But in today's video, we're going to focus specifically on the GCSE content you need to know, because as it is a required practical, it can make up around 10 to 15% of your exam. So this practical along with others, and that can lead to you writing methods. It could also include you interpreting data or plotting data on a graph, for example. And these are all kind of skills as a scientist we kind of need to nurture and kind of focus on. So I'm going to be doing that today. Like I said, in this practical, you may have done this in school before, in a lesson before, and it's very unlikely that you're going to investigate how sleep or caffeine can affect your reaction time. Often it will be things like how much noise can affect your reaction time, or practice, or something like this. It's a bit more easily manageable in a lesson, and more ethical as well, I would say as well. So let's actually look at how we do this practical in a method now. So here is the method for the reaction time practical. And as I would say, we always want to make sure we know what the aim of this practical is. So we're determining whether a factor such as noise levels or distractions can affect someone's reaction time. And we would think naturally the hypothesis would be, well, to be honest, if it's a noisy environment, you're less likely to be able to focus and your reaction time would increase. So you wouldn't be able to respond as quickly. And that's something that we're going to see if that happens. So I'm going to show you some data in a moment. So the first thing you want to do is work with another person, and you're going to label yourselves A and B, and you can see that in the diagram here. So person A will hold a meter ruler stick with the 0 at the top of person B's thumb, and you can see that in the diagram there. Person B will hold out their hand with their arm resting on a table, and that's really important so that you can make sure that they aren't trying to get nearer or inch closer to the other person's hand. That often can happen. So making sure that that person who is trying to catch the ruler, they have their arm resting. And also that means that it's at the same height each time. Once the person A, who is going to drop the ruler, is ready, they are going to drop the ruler without telling the person called person B. And they're going to do this in absolute silence to begin with. So in this practical, we're investigating how noise levels act as a distraction and how that can influence reaction time. So the first round of this, you're going to do it without any noise at all. And this can be quite hard if you've got a class that you're doing this with, class of 32, if not more. It can be quite challenging to get everyone completely silent, but it's very good. It's very funny to try and do that. So have a go if you can. But also round 2, you're going to then incorporate some noise. Maybe people can chat. You can even have some music playing, that kind of thing. So there's going to be 2 sides to this experiment. And each time you drop the ruler, the person B is going to catch that ruler. And essentially, you're going to measure just above where their thumb is. You're going to measure that amount of length, or how much is on the ruler, and then you're going to put that into your results table. After several repeats of this, you're going to calculate a mean average, and then you're going to swap over. So person A gets to catch, and person B gets to drop the ruler. Then you're going to do the same thing, like I said, now with music. So that first time was without any sound, and then the second time is with music. And essentially, you're going to do the same thing where you get lots of repeats and calculate the mean, and then you can actually determine your results in a table, which I'm going to show you now. Okay, so here are some results from a typical set of data that I've just pulled together and I want to show you. So you can see we've got person A and person B in round 1 and round 2. Remember, round 1 was without any sound, round 2 was with some music or some chattering that was going on. And we've got all the different attempts, including the mean average, which we've calculated from those attempts. And as you can see, what does our results actually show us? Well, if you have a look down the table, you can see the numbers are very similar, which is what we'd kind of expect. It depends really. You can often get lots of people who have very, very great data where it's very close together. Some people have data that's very skewed, and that's why you need to take lots of repeats. One thing I will say, though, in this particular data, it says the distraction of music increases reaction time, causing each person to catch the ruler at a slower pace. And this makes sense, as often music can be a distraction or just some noise, something to distract us away from the task that we're doing. The one thing I will say as an evaluation, you might find that the person who's catching it gets better. So they start actually having a faster reaction time. And that can be because they've actually practiced the skill more and more and more as you do more repeats. And that's something that you kind of want to mention in your sort of results and why you might see data like that, because of the practice element. Something else to mention as well is you want to consider the people who are doing the experiments. So some people may have other factors like the amount of sleep or the amount of caffeine. Those sorts of things can also influence it. So if we were to do this on like a clinical trial where you have strict guidelines, people who would do this practical, they would have the same amount of caffeine, the same diet, the same amount of sleep, all of that kind of thing to kind of control the other factors that could affect reaction time, which leads me nicely onto some required practical tips and kind of variables, which we're going to discuss now. So I've talked about control variables that are really important to mention at this point because, like I said, distractions can occur in lots of different ways. So it could be amount of sleep, the amount of caffeine, amongst other things. So to kind of ensure that those variables are not affecting the results, you want to make sure they're controlled as best you can. Obviously, if you're doing this in a class or in a lesson, everyone has very different lives and different circumstances, so it's going to be very difficult to control. However, that is something you could mention in your method anyway, because obviously when you do write a method, you want it to be as accurate as possible so you get the best valid outcomes, and I'll talk about that in a moment. But just as a bit of a brief recap on variables, remember that variables, there are 3 of them. There's the control variable, that is essentially what you keep the same. It is also the independent variable, which is something that you alter or something that you're changing. And also the dependent variable, which is something that you're measuring. So in this case, the control variables would be things like I'm controlling for the same person. So person A is constantly catching the ruler. But also something else you can keep the same if you had the ability to would be the amount of sleep that person got, the amount of caffeine that person consumed, if at all any. Also, the other thing is the independent variable, something that you're changing each time you're altering. What you're altering essentially is the fact that you're adding a distraction in. And what you're measuring in terms of the dependent variable, you're measuring the reaction time. In this case, you're actually measuring the length of the ruler that you're catching. The one thing I would say is you can also use conversion tables at this point to convert it into a time. So you actually have a reaction time if you wanted to, or you could just look at the length and that would give you a good indication as to how fast that person has caught the ruler. So SID-SAM, which you can see there, is a great way of remembering the control variable, independent and dependent, because a lot of students find that quite tricky. So that's just a bit of a tip for you guys. Also, just to mention, because it is a required practical, like I said, you could be expected to write a method. And this leads us on to something called a leveled answer. So at GCSE, you could write a method and it could be worth 6 marks. And it's often a full page and it's got loads of lines. It looks quite intimidating, but it's really not, because what it's asking you to do is to use bullet points so it makes logical sense. So number 1, you do this, number 2, you do this, blah, 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 blah. When you write your method, it's really important to write in a logical flow. So you want to make sure that it makes sense and that you're writing it in a way that if someone was to take that method, they could actually get valid results from it and they could actually do that experiment easily, especially if it's someone that's never done that experiment before. So that's kind of the way you want to write it. The other thing is, if you find it quite challenging to write a lot, remember, you don't actually need to. You have lots of lines, but you don't need to write huge amounts. As long as you are concise, that's absolutely fine. And I would recommend, if you find it challenging to remember the key steps, using diagrams to jog your memory will really help you, especially if you find writing a long amount of information or trying to retain quite a lot of information. That can be quite hard. A diagram, remember, pictures say 1,000 words. You can use that to help you construct your answer as well. And then the last couple of points is, if you also are looking at your next stage, so maybe you've done your method, remember to also include how you're going to track that data. So let's say you're catching the ruler each time. So what are you going to do with it? You want to make sure you put the data in a table, you calculate the mean. Those are key points and ideas that will make your method much more valid, and how you would actually get better marks essentially. So with a leveled answer, it's not just about writing 6 bullet points to get 6 marks. Unlike in other questions, you need to really be looking at top leveled answers. It's kind of a range. So answers to 4 to 6 marks, level one. Those answers essentially will be the ones that have that logical flow through them. They kind of give valid outcomes, and they kind of have a realistic um, sounding sounding board. So essentially, when you read it, you go, okay, if I was to do this practical, this is what I would see, this is what I would need to do, this is what I would need to collect in terms of data. So what you'd see in this practical is that over time, the person who's catching it would actually probably get better at it. And it's the same with other practicals. So these tips kind of apply to other practicals as well. There's no real observable results here, but in other practicals, maybe the food test one, there'd be color changes and things like that that you'd actually add in as well. Like I say, if you are finding required practicals quite challenging and writing methods, I would recommend you use flashcards. Those are really great to track key ideas. So you can't write too much down, you just have to write the key points. But also, if you are maybe in year 9 or in year 10 and you've stumbled across this video and you want to get ahead and kind of focus on revision for your GCSEs, I would actually recommend you keep a notebook that you bring to science lessons whenever you're doing a practical. And that way you can actually write your required practical notes in them. And although lots of teachers like myself, we will give you the method and we'll give you your own book and things like that for the lesson, I actually would recommend, if I was to do this again as a student, I would have my own notebook that I would make my own notes in, so that I could keep track of what's going on. And that way I could figure out, okay, well, we've done that practical, we're going to do this practical. And sometimes actually it's nice to reflect back on them and see what went well. And that's a good tool to use in any evaluations questions they could ask you as well. And that's it from me today. Thank you so much for your time. I've been the GCSE science teacher and you have been curious. If you did enjoy this video, feel free to give it a big thumbs up, share it with someone else, and also subscribe. If you have enjoyed this video and you want to learn more, feel free to check out the videos and playlists that I've linked here for you. But also, I have an Instagram and a TikTok. Everything is at the GCSE science teacher as well. So if you'd like to go and support those channels or platforms, feel free to. And until next time, have a great day, and I'll catch you in the next one. Thank you. Bye.